Actually, it's a little bit after 6. So we're recording this. Linda, I just sent those things moments ago,
Yep.
but you found them, so you're on top of things as always. So this is great. So good evening, everyone, and let's just begin. So I will advance the slides. These slides are in your syllabus tab if you want to watch them and make them bigger or something like that. That's all good. Okay, and what I have here is Jim is going to make some remarks. I'll give Linda an opportunity to make some remarks, and I'll expect Linda maybe give me a little bit of a traffic report about, how are people engaging in the, guided study groups or whatever. We will be doing this community building group work. Linda, sometime you and I maybe want to talk about if this is good. I think it probably is, but I'm interested in your opinion offline. That's good. What you will do is you will be tossed into groups. Linda will do that kind of, with an average number of people in the groups being about the same, but she'll just kind of randomly do it, I think. You should introduce each other and select a spokesperson. And then after we do this, we'll do a readout with the spokesperson. And so the spokesperson then is going to tell us who is in their group. You're supposed to choose a spokesperson. I'm not going to ask if they're drafted or what. I'm tired of doing that. I don't think I will do that anymore. But who is in your group? And just to have something to discuss, I would like for you to have people comment on their best day so far. And one thing I always hope for is that there are brighter days in the future, but I can talk about maybe what my best day is so far. And Linda, I'll invite you to ponder this as well, and we could do some sharing there. So this is best day so far. And by the way, as you're coming up with this, make sure that whatever you say is your best day is something that is shareable. And I have to tell you that I think it's important to do that because what your group leader is going to say is, well, Susie's best day was when she graduated from high school, and Sandra's best day was, her junior prom or something like that. And all those things are probably fine, but you don't want to say anything that's, inappropriate, I guess. And then also I will poll the groups for questions as we go around. Okay, and then Linda will do a wellness poll before we kick off, and we do have some content that we'll do and things like that. And tonight we are going to talk about normal distributions problems. We're going to finish that up. We'll talk about regression, contingency tables, and we're into chapter 5 on discrete probabilities. So we do have a busy evening. Okay, so let me begin just talking about my talking points, and we'll see where we go. One question that some people will ask is, where are we? Well, by my count, Linda, we're entering into our 4th week. And the semester either has 16 or 15 weeks, I think, depending on how you count it. That's fine. I think we're in good shape, but we're entering our 4th week, and that means that this is more or less the 1/4 point in the term. And for me, that means that we probably want to be about halfway finished with our statistics. I think we are there, and so I'm feeling good about where we are. In Michael Sullivan's book, we're on the we're into chapter 5, so that's where we are. So that's a little bit of a discussion from my vantage point about where we are. Let's see. On March the 9th, which I think is an evening when we have class, we will do a practice run for the way that the midterm is going to be proctored. And we will have guests come to our lecture, and in fact we'll go to a Zoom place, and so we'll actually do a dry run. I think this is useful, and we're going to have Ruth and, wow, I'm not remembering the other person's name, but there are 2 people from the testing center who will join us in class, and you'll have to go somewhere else to do that, but that's all good. So we'll look forward to that. That will make things go much smoother when we have the midterm exam over statistics on March 16th. I have asked you guys for, all right, so in class, we're having the statistics test, midterm, on March 16th. And no one, I think, now actually maybe I shouldn't say that, maybe only one or two people have mentioned accommodations. I want you to tell me if you have accommodations. Everybody will be accommodated, but we have to know about it in order to do it. So make sure you're letting me know about that if you have issues. Let's see. And one student asked a question about, I'm hearing a lot of feedback here. I did move my microphone, so maybe this will get better. And if you think you might be the source of knowledge, feel free to mute yourself and then unmute yourself later. Thank you. Somebody figured that out. That was good. Okay. Points for LSA. One student said, hey, Jim, I looked and it only said there was 1 point for this LSA. I'm not going to do any work for 1 stinking point. And that might not have been your class. That was probably from some other class. But anyway, that's like asking, how many bills do you have in your wallet? Well, you could count the number of bills, but what matters a lot more than the number of bills is what's the designation on the bill. And these LSAs do count a lot. Over the term, the LSAs will count for 1/3 of your grade. And so what you do want to be doing is getting good good grades on these, using them for learning, and they are going to count. And it really doesn't matter if I just count them as 1 point each or 100 points each. They count for 1/3 of your grade. So don't worry about what's there. And to tell you the truth, I often find it confusing if I say, oh, they're worth 100 points each, then students say, oh, they're worth as much as the midterm. No, they're not. The midterm is 1/3 of your grade. The final exam is 1/3 of your grade, and the low stakes assessment in aggregate are 1/3 of your grade. Let's see. I asked, where are you? I think we're going to, learn. Well, I guess what you want to do is you want to figure out if you're caught up or not. And if you're not caught up, you want to be getting caught up, because, on the 16th, that's actually, Linda, that's 1 month from tonight. In fact, we're going to have the exam, the midterm exam, and we'll talk more about that as time goes on. I think that's all I want to talk about. Linda, do you have anything you want to share with the group?
Not especially. As I sent out in an email yesterday, then our GSG yesterday from 5 to 6 was canceled, and that'll be rescheduled on Friday from 5 to 6. So feel free to use the Monday link when you join that.
Okay, excellent. And Linda, have people been engaging in the GSG? I mean, I'm hoping so.
Yeah, we're getting about 2 to 3 people regularly, so I'm pretty happy with it.
All right, and people are certainly invited to go, and Linda is much nicer than I am, although you're certainly invited to my office hours as well, and I guess I'll be having office hours after this is over. Okay, so very soon Linda's going to be figuring out how many of you are. She's going to break you in groups. You will select a spokesperson. You will introduce each other within the group, and I'm going to ask the spokesperson who was in the group. And I want everybody, and I'll even ask Linda to report on this, and I actually have an answer to this myself as well. And so best day so far, and you can talk about what the event is. Do make sure it's shareable. And then you also, as the group leader, want to poll to find out if there's any questions that people want to ask, and then Linda and I will answer them. So Linda, how many groups do you want to break this into? Linda, are you still there?
Yeah, I'm thinking 4 groups.
Okay, so Linda's going to break you into 4 groups. You elect a group leader after you introduce yourselves and talk a little bit. but then you talk about these things, and then we'll do some readouts of this best day, and certainly we always want to answer your questions. Okay, so Linda, and how long do you think we're going to leave them in the group, Linda?
Probably about 10 minutes.
Okay, so Linda will watch the clock and do your thing, Linda, please. And Linda, I don't know if you can stick these people, a few people I think are just coming in, so maybe you can stick them into a group or something, I don't know.
Yeah, I can just randomly put them in a group.
Okay, so we'll do that, and let's see. Looked to me like it was about 12 past when we did that, so at 22 we'll bring them back. Linda, have you established your, I'm going to say thesis project, but whatever the capstone thing is?
I did have a topic picked out, but it's a little difficult to do with COVID going on, so I'm going to have to figure something else out.
What did you pick out?
I wanted to do something on how instructor behaviors modify student anxiety levels. But kind of hard to do that without being in person. So
Well, I do understand that, but if you have an instrument that you were thinking about using or something like that, I would be happy to say, oh, here's my students. and you could do that. And now I'm not saying that's even the interesting the same way. But you could probably compare and contrast the net delivery, who get much less of me, and that's the discrete math, versus these guys that probably get an overdose of me. And again, maybe it doesn't make any sense, but I don't know. Maybe it makes absolutely no sense here, but I did want to at least offer that.
Well, I appreciate it. And I may end up taking you up on that.
I'm not trying to increase anxiety, but I'm continuing to cover material beyond where we are. But I think that's okay. So.
Yeah, I think what I'm looking at now is actually doing like a case study kind of deal about working with our favorite blind student. So
Well,
that
I
could
think
also
that
be pretty interesting.
I think that really could be interesting. And in fact, there might be some footnotes, because I'm not really sure what's happening with Zach in the statistics class. But actually, I probably should reach out to him and, just try to find out. So.
Yeah, I actually just had an appointment with him today, so I think he's doing pretty well. It's just a lot of figuring out how to use Excel without using a mouse, basically.
I had a real hard time directing him to use technology, and maybe Excel doesn't do a lot of the calculus stuff, but I thought the TI did a lot. The TI, I feel, did do a lot of it, but I don't know.
Yeah, I just remember his charger wasn't working or something, or he couldn't find it, and that kind of threw a wrench in it. But
I think actually there would be a lot of interest in that topic. And it's not like there's a million students out there that it applies to, but I think it could be a fascinating thing.
yeah, definitely.
Yeah.
What are we at, like 9 minutes or so?
It's 19, and I think I said 22, and I don't care if you err on the side of bringing them back at 21 or something. I'm just leaving that totally to you.
Okay. I think I'll bring him back early then, because I don't see anyone in group 3 talking. So.
Okay.
Oh. What? The classes? Oh, we're back.
Okay. Do I have a group 1 spokesperson?
I am Paula. We were in the
Okay,
group 1.
that is okay. So I think that is OLA. I think that is how I spell that. Okay. And Paula, I'm just putting it here because, well, you don't want to know, you don't need to know this, but I was looking around for a pencil, and I found a pencil, but the lead was broken, and so I say, well, I will just do this. Okay, so Paula, let's see. So who all was in your group?
I was with Hannah and Anna.
Okay, that is good to hear. And can you tell me, and include yourself in this, what is your and just by student, what was their best day so far in their life?
So for Hannah, it was when she went to Wyoming. For Anna was actually Valentine's Day. She spent it with the person she loves. And for me, it was the day that I got married.
Okay, so there's a lot of love flying around in that. Linda, I said I would ask you, what is your best day so far? And Linda, of course, is very talented and she's very young, and so I'm sure she has really bright days in front of her, but what's your best day so far?
Oh my, that is quite a question. Probably when I initially brought my dog home. She was the sweetest puppy.
Okay, that's and I know some people might not look at this, but I have a daughter who has dogs, and so three of those were love stories. Actually, mine is kind of a love story also. It was either the day I got married, or the days when our three children were born, and so those are the best days so far. And actually, those will be hard to beat, and I am old, but anyway, we have those. Okay, Paula, any questions in your group?
Yeah, we have just 2 questions.
Okay, now we're going to do one and then we'll come back. Okay, so you'll get the other one, but not now. So what question you want to ask right now?
One of the questions was, how much time do we get for the midterm?
Uh, okay. And by the way, this is going to be a little bit of real-time rambling with Linda. I guess I'm going to suggest, Linda, that maybe I will give the students 2 hours to do the midterm. And the midterm starts at 6, so I'll say it's like 6 to 8 is what I'm thinking. Now, I could say, oh yes, and we should have the students come back, and I thought about that after the test, but I think students will be kind of emotionally exhausted. They probably will want to leave. And I would say, yeah, but I want to lecture. Well, I can lecture, and as you know, I put lectures on YouTube for you to watch. So Linda and Paula, I'm just making up that answer right now. Linda, is that okay, you think?
Yeah, that sounds good.
Okay, so let's, Paula, and we just made up the answer right now, but it'll be you'll have 2 hours, 6 to 8, and then you'll be finished for that evening. Okay. All right, so
Okay.
that's good. And thank you, Paula. And Paula, I will return to you because you said you had 2 questions, so I'll come
Okay.
back there later or something to try to get another question from you. I'm not trying to ignore that. There was a group 2. And so who do we have being the leader of this group 2?
This is Kathy. I'm the leader of group 2, or the spokesperson, I should say.
Is this Kathy, K-A-T?
Yes, Catherine, K-A-T.
H-R-I-N-E. Oops, damn it.
Just Kathy, K-A-T-H-Y.
All right, well, anyway, okay. All right, so who's in your group and their best days so far?
Okay, so we had Destiny, her best day. Well, we all talked about how it was very hard to pick out a best day, so these are one of our best days, not
Okay.
necessarily best. We've had a lot of best days. Okay, Destiny said she had a really awesome Colorado trip to visit a friend that moved there. They were in the mountains, dirt biking, etc., and it was a great day. And Caitlin said having her son Benjamin was the best day of her life, and the good thing about that was, luckily, she doesn't remember it because she had a C-section. So she just had her son and didn't remember the pain. And Mariella said visiting the ocean is her favorite, one of her favorite days. She went to Cancun and Tulum and the Atlantic Ocean or the Caribbean Ocean, Caribbean Sea. I don't remember when she went, but that was an awesome day for her. And Tori said when she had her son Freddie this summer was her best day. And the hard thing about that though was it was a COVID pregnancy, COVID delivery. So there was no baby shower. Almost no one was allowed to go to any of her appointments or visit in the hospital. And the good part is spending a lot of time with her baby.
Okay. All right. So there's a lot of love there. Do you guys have a question, or you can have more than one question, but we're taking one question at this time.
We didn't have any questions that we actually didn't get to that, so I'm not sure. No one had any pressing questions that they brought up.
Okay, now this X doesn't mean anything bad, except I'm not going to come back and ask you about questions again.
Sure.
That's all that means.
No problem.
Okay, so let's go to, I think there was a group 3 here. And so group 3 was somewhere.
Yeah.
And who is the spokesperson out there for group 3?
It's Elizabeth.
Okay, so Elizabeth. Okay, so Elizabeth, that is good. So who all was in your group, and what were their best days?
So Jasmine's best day was when her son was born. Carolina's best day was when she was married. Lizbeth was when the first time she went to Mexico, and mine is when I got my dog.
Okay, that's great. What kind of a dog do you have?
Borderline collie mixed with the hound.
I think you said borderline collie, and I don't know if that's the same thing as a border collie, but border collies are very smart dogs.
Yeah, mine's not very smart.
Maybe yours is a borderline collie, but I also will tell you that you don't have to be smart to be loved, and
That's
so
true.
you know
Very true.
yeah, I mean, so that is okay. All right, so that's good. Do you guys have a question that you'd like to ask at this time?
We didn't have any questions.
Okay, now that's what this little X means. Just means I'm not going to come back and ask you about questions. It doesn't mean anything bad. Okay, and now I think we get down to our last group, and so I'll ask whoever is the spokesperson for group 4 to come online.
That's
and
me.
tell us who is okay, and who is me this time?
Lori.
Okay, Lori, Laurie. I'll spell it that way anyway today. Okay, so who all was in your group, and what were their best days?
So Jenna was in my group, and her best day was when she got her dog, Lila, about 2 years ago, and her dog is a pit bull mix. Maria's best day was last year she got her associates in art, and she is the first in her family to go to college. So it was very exciting.
That's a cool thing. Go ahead.
And then Cassandra, her best days were having her kids, but since she had to pick one and she has 2 kids, she went with her next best thing, which would be when she and her husband bought their first house.
Okay. All right. How about you?
I didn't say anything. That's a really, really, really big question.
Yeah. Okay. All right, and that's okay. I'm not trying to pry with that. Did your group have any questions?
We did. We had a couple. The
Ask
first
one
one,
now.
yeah. The first one will be each class, we don't seem to circle back to the prior class, kind of like going over the LSA so that we can figure out what we did wrong or what we did right, and really kind of solidifying one class to the next.
Okay. Let me tell you what I plan to do, and I've done some of this, and I'll take that as input that I probably should do some more. But I did publish solutions to 1 or 2 of those, okay? And when I say publish solutions, I mean I made a video about it, okay? And I think that's probably Lori and group. I think that's probably how I would like to do it, just because then it's out there, you can look at it later, and things like that. So I'm thinking that's a good thing. Now you guys can always, and I know now the way we do this, and I don't know if we'll always do this community time or not at the beginning, but Now the way we do this, we don't necessarily do that, but you guys should feel free to ask questions about the solutions that I post there. And you could ask the solutions in class if you want to. You could ask about the solutions that I post in the Linda's GSG things. You can ask them in my office hours and things like that. So I do tend to, want to do that. I'm not caught up on my grading, but I will get caught up on my grading. But it's not. Oh, I know. Now I remember, Lori. You made me think of it. That where are you? There was a question a student said. It says, I don't know where I am in this class. I need more, more feedback and stuff like that. And my answer to that student is, well, you are going to get feedback, but you're pretty much in good shape so far, because if you're doing the LSAs and understanding them, you're in good shape. So I'm thinking right now, I'm thinking that you are okay. And I don't just mean you Lori, that's the generic you. I think you're okay, unless you're saying, oh, I'm really struggling. In that case, I'll give you, the advice I always give to students is, well, get engaged with Linda or me or Tom Topol or come to my office hours or something. So let's don't let that stay there. So Lori, my answer to your first question is that my plan is to publish solution videos for the LSAs, and we'll deal with questions in office hours or in class if people really bring them up, or in guided study groups or things like that. Okay. All right. So thank you, Lori. I'm going back to Paula because I think there may be a question back there yet. And Lori, I will return to you for your last question. Paula, you had another question, did you?
Yeah, one of the questions was for the midterm, do we have to put the data? And let's say we're a little bit slow doing it on Excel, will we have extra time for the midterm because we take longer?
Well, the midterm's going to be, I'm guessing, 10 to 12 questions, and some of that will involve data. And I'll probably try to have data available, but you should be pretty quick about doing things. I don't want you to spend all your time there entering data, although Linda probably feels a bit put upon because I don't always type those data things in, and sometimes I give her things, and she has to type them in. But it also gets very boring doing bear problems all the time. We'll do some more bear problems tonight. So I guess the answer is, if it's a small amount of data, I might ask you to type it in. I also will probably provide in Blackboard, where you can get at it, some data files that are available. Linda, you want to say any more about that?
So last semester when we had this class, then I believe students only had an hour and 15 minutes or something for the midterm. So I think 2 hours is plenty of time. Even if you have to type in some data, then it's not going to be an excessive amount. So you can expect any data that you'll actually have to type in will probably be somewhere between 20 to 40 data points, maximum. So I wouldn't worry too much about spending a lot of time typing in data. It's more about being able to manipulate the data once you have it written out in front of you.
Okay, so thank you, Paula. And Paula, I think that's the end of the questions that you said your group had. So Lori, we're going back to you, and this will wrap up the questions, I think. But please go ahead, Lori, with your last question.
And then my group's last question is that I think there's still some confusion as to how this relates to sonography. How are we connecting these things that we're learning and these LSAs to sonography?
Okay. Well, okay. Now, in one of the videos, I think, and Linda, you're watching these videos or not so much? I don't know.
Occasionally, depends if people show up to the GSG or not. I've seen most of your lectures, though.
Okay. And so I'm asking you because I think I did. Didn't I give a lecture about a research paper in ultrasound where they were talking about different kinds of pregnancies, and they did regressions and those kind of works.
If you didn't this semester, then you did last semester, so it's
Well, I
out
think
there.
I did. I guess what I'm going to say, Lori, is I will take your question, but I'm pretty sure I did it this term too. In fact, I used a different paper this year, and in fact, it was right before the lecture about specificity and accuracy of diagnostic tests and things like that. And so they were talking about the value of ultrasound in predicting these, and actually I think it was malignant tumors in breasts, I think. So I'm going to say that that was an example of what we're really talking about there. But I will try to answer your question a little bit more explicitly. I'll say, hey, it's in video. I don't know. Somehow I'll refer to the video so that you know which one it's in. But I did go over that. And I don't know if anybody else out there remembers this video. I remember making it, so I think it is out there. But anyway, so
But that
yes, it
sounds
does.
like that sounds like it's related to research relating to sonography, but not necessarily the field of sonography, because I don't know that any of us are going into research. So,
Well,
I mean,
okay.
eventually maybe, but
Yeah, well, I want to make two comments, and I probably made these in the videos, but first thing is, don't sell yourself short, okay? Because I think you are talented young women, and you might start doing the ultrasound technician kind of thing, and you might like it, and you say, I really like that, but boy, I could do more. I want to do more. So that is research. The other thing that will happen is, and you might say, yeah. Kathy was just. It was about tumor malignancies. Okay, but the other thing that I'm going to say is, wow. And Linda complains when I tell stories, but I am going to tell you a story. You might say, I'm not a doctor. I'm just a tech. Well, I don't think you want to think about that, but I am going to tell you a true story, and this is a true story about my sons. And my oldest son got angry at my middle son, and he made a fist and he punched my son Charlie in the head. Now, that made Charlie cry for a very short time, but Charlie was just fine getting punched in the head. But Jeremy's arm swelled up about 2 times the size because he broke a bone, and the swelling wouldn't go down. So anyway, I took him to the doctor. And I'm not going to tell you the name of this doctor because this is a bad story about the doctor. But anyway, the doctor says, well, yeah, that doesn't look so good. We want to take a picture of it. Okay. So he said, go across the hall and do the radiology. And please hang with me because there is a point to this story. So I went over there with my oldest son and I went in. And by the way, another doctor, later on, after we got the cast on it, I was with another doctor, and he says, your problem was that is called a boxer's fracture, and you hit him wrong. You have to hold your fist differently when you hit someone in the head. And so another doctor showed him how to do that. But anyway, I went over there and I got the X-ray, and so the X-ray tech came out. And by the way, this is an X-ray technician, just like you guys are going to be ultrasound technicians. So she brought it out and she says, oh, here it is. And she says, take it over and show it to the doctor. And so I took it over to the doctor, waited in his room again. I went up there. He threw it up on the screen, looked at it, and he says, no, that's not broken. So it'll just, the swelling will go down, not broken. We don't need to do any cast or anything else. And he says, hey, and take this back to the radiology, across the hall because we keep the files there. So I went back and I gave it to the radiologist, the same person who brought it out to me the first time. And again, she was a radiology tech. And I said, well, darn it, it's not broken. And she says, she says, take this back to the doctor and tell him he probably should look at this again. And I went back, and the doctor, of course, I don't think he even realized I was there before. He threw it up there, but I did tell him, you really want to look at this carefully. He threw it up there, and he says, oh, yes, look, it is obvious here it's broken. And then he pointed to the fracture. Now, my point is that, yes, you guys are techs, and your job is not going to be reading these things about malignant tumors and things like that. But your doctors are not gods. Your doctors make mistakes. And you guys can be really great associates for them. And I thank God that there was a radio tech who knew how to read x-rays, even though it wasn't her job. And she knew that there was a fracture there, even though the doctor missed it. So she was really good at her job, and he wasn't nearly as good at his. But that's one of the reasons that even if you're not doing research, you might want to know about those things. Because if, and in this, I guess this was about tumor malignancies, if you see something there and a doctor, is saying, oh, there's nothing there, or you hear the reading, and you really thought you saw something, and you think you have to do that carefully because you don't want them to think you're a know-it-all, but you really are concerned about the patient's welfare. And I'm sorry that was a long story, Lori, but I think that's a good story about this. And maybe everybody left, I don't know. Okay, anyway, that's my story. And that's why I think a research paper can make sense. And that's why it's useful for you to understand this research. And some of the problems we have deal with that as well. Linda, let's do a wellness poll, and now we'll find out how many people really are out there.
You got it.
Thanks, Linda. Okay, I'm just going to call it now. Most people are doing okay. Someone's doing great. That's all good. If you're struggling, my advice to you is engage. Go to Linda's help sessions. Maybe you want to buy the book that I've talked about, or rent the books. Maybe you do. I don't know. Linda's available. Tom Topol's available. I'm available. Interact with us, and we'll find out what you need to do better, because I think in a large measure the ball is in your court. Now, if you bring it to us, then we're sharing the ball in our court, and that means we can work on this together. Okay, so that's good, Linda. And I'm going to advance to a normal distribution problem. And Linda, if you feel up to this, we're just going to do some of these things. Now, this is the scheme that we talked about last time about X space and Z space. And Linda might do this. And I remember I told you there were two great problems. Given the numbers, find the probabilities. Given the probabilities, find the numbers. So we're not going to go over this again, but these are the tools for doing a number of these problems. And you do have tables. And one table is here. And Kathy, I'm going to call on you in just a moment. One table is here, and that's in your materials, and so it's there if Linda wants to refer to that as well. And the other table is here, and those are the two normal tables that we have, and so that's good. And then we're going to do a problem here. I'm going to read this problem in just a moment. We're going to do this, and Linda, I'm probably going to ask you to take the lead in this discussion if you're up for this, and if not, I can do it. But Kathy has a comment. Go ahead, Kathy.
I just was wondering, the slide you were showing a moment ago with the formulas for going from Z space to X space, it looks almost like two slides overlaid. I can't read any of the formulas. I don't know if it's just on our end, or is there another slide you could use?
Well, I think if you look at your slide, don't look at the slide that Linda is showing, but look
Okay.
at your slide in the syllabus tab and use just a slideshow button. I think it will show up well. And Linda and I messed around with this last time, and she figured out a way to do it. But she's just going to be talking about that. So Kathy, my real suggestion is go there and look at this slide in that deck of slides, and it will be clear. I think this has to do with either Blackboard Ultra or something, and I don't want to debug it now.
Do you know if it will kick me off of Collaborate Ultra if I try to go back, or how do I open up the slideshows you're talking about?
Kathy, if you open up the syllabus tab in a new tab, so leave Collaborate going, just open up Blackboard in another tab,
okay.
Then you can get the PowerPoint from the syllabus tab and open it using PowerPoint on your computer.
Okay, and Collaborate will just stay on in the background?
Yes. You don't need to have Collaborate going on in front of you to have it going.
Okay, wonderful. Thank you.
But you said background, it's going to be going in whatever tab you left it in. Okay. All right, so here we go. And this deals with gestation periods. And again, this is a medical application, okay? Now, those malignant tumors actually were an ultrasound study, but this is that. And by the way, Laura, I am going to go back and answer your question even another way, but a way beyond this. The founder of the ultrasound program at the College of DuPage partnered with the math faculty in defining what should be in this course. And she said it should be half statistics and half physics. And over time, I've come to think, yeah, that's probably a good thing to do. But anyway, that was a comment. Now I'm reading this. So the lengths of human pregnancies are normally distributed with mean mu is 266 days and standard deviation is 16 days. So what proportion of pregnancy last more than 270 days? Okay, and then Linda, so let's go ahead and just work through this problem. Go ahead, Linda, please.
Okay, so since we are currently in X space, then to figure out the proportion of pregnancies lasting more than 270 days, then we're going to need to go to Z space. So my current X value is that 270. My mean is 266, and my standard deviation is 16. So all of this I'm just getting from the problem. Now, if I'm in X space, and I'm just going to kind of doodle up here, then more than 270 days is going to be above that 266. So my picture is going to look something like that. Now I just need to figure out what my Z-score is. That way I can go back to those normal distribution tables and figure out what number is inside of the table for those Z-scores and then fill in the shaded region. Since we know that our normal distribution tables are going to give us the area to the left of whatever value. So we're going to need to do 1 minus whatever we find in the table to get the area to the right. Kathy, you have a question?
Wouldn't you be already in X, or wouldn't you be in Z space already if you're, like, what I mean is the mean is 266, not 0. So wouldn't that mean you're in Z space going to X space?
So this means that we're in X space going to Z space, because remember, Z space is when the mean is 0 and the standard deviation is 1.
Okay, I was getting it. Okay, thank you.
Okay, so then I'm just going to put my work under part C here. So then Z is going to equal that 270 minus 266 over 16. And all I'm doing to get that is doing X minus mu over my standard deviation. Because remember, that was our formula that we're given in the Grace Notes. So if I plug this into my calculator, then it looks like I'm getting 4 over 16, which is just going to be 1/4, right? So 0.25. So that is my Z-score. Is everyone okay with that?
Yes.
Okay. So then since I have my z-score, which is 0.25, then I'm going to go back to my normal distribution table. And if I zoom in here, and give me 1 second. So 0.25, that's going to be in my third row. And then if I go all the way across to the 0.05, so I'm looking right here, and I'm getting 0.5987, okay? Now remember, since we have this picture, then I'm trying to find the other side of my curve, right? So if this is my 0.25, this is the 0.59, what was that, 87? Yes. So I'm trying to figure out the other shaded area. So I'm going to do 1 minus that 0.5987. And let's see, I believe that's going to get me 0.40 and then 13. So this would be my proportion of pregnancies lasting more than 270 days.
So a little over 40% of the pregnancies would last that long. Okay, that's good. Linda, let's go back and let's do 1 or 2 more of these. And we're not going to do all, I don't know, 10 of them or whatever is here. No, let's go back to the, yeah, let's stay with this one just because we got this. Okay. And Linda, do you want to do B or C?
We should probably do C. That one seems a little bit more complicated.
Okay, good. Go for it, please.
So now we're trying to find the proportion between 240 and 280 days. So if we remember what that picture looks like, then my 266 is right in the middle, my 280 is going to be above that, and the 240 is going to be below that. So the area that I'm finding is actually this middle region. So remember, the way that we find that is we're going to figure out the proportion for the bigger region and then subtract off the proportion for the smaller region. So it's almost like we're doing 2 problems in one. Everyone okay with that?
Yep. Thank you.
Okay. So then to find my z-scores for each of these, then I'm just plugging them into that same equation. So I'm doing x minus mu over sigma. So in this case, that would be 280 minus 266 over 16. And then for the second one is going to be 240 minus 266 over 16. So if we plug these into a calculator real quick, then let's see what we get. So 280 minus 266, that will give me 14 divided by 16. So I'm getting 0.875, which since we just need 2 decimal places, I'm going to round that to be 0.88. And then the z-score for my other one, then 240 minus 266. So that would be negative 26, I believe. And I'm dividing that by 16. So I'm getting a negative 1.625, which I'm going to round to be negative 1.63. Any questions with those 2 numbers?
Wait, what was you had negative 26 divided by 16, and what was it? Why did you round?
So I got negative 1.625.
Okay.
I'm rounding it to 2 decimal places because that's all that's included on my table.
Okay. All right. Thank you.
We all good? No questions? Okay. So then now that I have my 2 z-scores, then I'm going back to my normal distribution tables, okay? So I'm going to need to use both tables since I have a positive number and a negative number. So let's start with the positive one, get that number, and then we'll subtract off whatever proportion is given by the negative z-score as well. So starting with the positive one, then my z-score was 0.88. So if I zoom in there, then I'm looking for 0.8 and then going to the right until I get to 0.08. So let's see if I can point that out for you guys. And we're getting 0.8106. Does everyone see that? We all good?
Yes.
Okay.
Yes.
Yes.
So I have that z-score. I have that proportion. Now I'm going to use my other z-score, which was the negative 1.63. And I'm going to go back to this negative table. So let's see, negative 1.63. Well, here's my negative 1.6. And then I'm going across to the 0.03. So that's going to be 0.0516. Does everyone see that?
Yeah.
Okay. So when I subtract those two numbers that I just got, which as a reminder were 0.8106 from the last table, and then I'm minusing that 0.0516, then I'm getting 0.7590. Yes, Kathy.
I had just had a question about labeling. So when we were finding, before we transferred to our z-score, and we had, like for the first one, we had z equals 0.88, would that actually be a percent? Or how would we differentiate that when it becomes a z-score, we would say like z equals 0.8106 once we find the score on the z table? Are they called something different before we find, like is one the percent and one is the z-score?
Yeah, so the 0.88 was the z-score. So that would be z equals 0.88. These would be your proportions.
Oh, okay. Okay.
So these are the numbers that the problem is actually asking for. The z-scores are just there so we can get to these.
Okay, so the last one is kind of your percent.
Yes. So
Okay.
this would be about 76%.
Okay, thank you.
And Kathy is asking, of course, a good question, but it's really crucial that you remember that the numbers are on the outside and the probabilities are on the inside. Now, Linda, we're going to go back to that problem for a moment, but I'm just going to ask you some questions. Linda, what great problem was this? One of the great problems was given numbers, find the probability, and the other great problem is given probabilities, find the number. Which problems did we just do?
So because we started in X space, then we were given the numbers and we found the probability.
Okay, good. Can you go back to the narrative of that slide? Because I'm not going to make you do something more with this one, but I do want to throw out a couple of things here. Okay. What does last more than 280 days? What does that mean in part D?
So that would mean that your picture, if I can get my pen to work, would be shaded to the right. So give me 1 second and I'll draw a nice little diagram of that. So your 280s right there, and if we're looking at more than that, then it would be shaded like that.
Okay, now in part E, it says last no more than. What the heck does that mean?
So that would mean that 245 would be the maximum. So you would be looking at the shading to the left.
Okay, And let's see, actually that one, I think 266 was the mean, so it'd be on the other side, but still it is going left, and I agree with Linda. Lori, what's up?
Is proportion is just the same thing as percent, or is it just, that's just how we're notating it in these questions?
They're extremely similar. Proportion is usually given as a decimal, whereas percentage would be given with a percent sign. So, I mean, the proportion for the last one was about, like, what, 0.759? But you could also say that it would be 75%. So,
Okay, so they're
basically
the same thing, it's just the way that it's written. So 0.79
yeah, you're just
is
wording it
79%.
slightly differently.
Okay,
Yes.
thank you.
All right, Linda, one last question on this, then we're going to look at the next problem. But in problem F, it says, are very preterm babies unusual? Now, I did talk about what makes something unusual previously in these lectures. And if you're dealing with normal distributions, what makes something unusual according to our rule of thumb, according to the Sullivan's text, according to my lectures? So Linda, what makes something unusual?
So there's two different rules of thumb. It's either less than 5% chance of happening or outside of 2 standard deviations from the mean.
Okay, so if I ask you a question like that, you have to, compare the number you get to less than 5% and so on. Okay, and this is just a comment that's neither here nor there, but there's really some incredible things happening in neonatal units, and many babies that once upon a time would struggle to survive, they end up not just surviving, they end up thriving. Linda, let's go to the next problem, please. Okay, I'm going to read this, and then I'm going to ask Linda to do, actually we'll probably do both of these, and I think we'll see how it goes, but we're going to be, well, it's 7:02. I think we're going to finish this problem before the break because I think that's the thing to do. Okay, reading rates. The reading speed of 6th grade students is approximately normal. That means it's normally distributed. The mean score is 125 words per minute, and the standard deviation is 24 words per minute. What is the reading speed of a 6th grader whose reading speed is at the 90th percentile? Linda, what great problem is this?
So this would be the opposite. We're starting in Z space and going to X space.
Okay, very good. So Linda, would you be willing to embrace part A, please?
Of course. So the first thing is understanding what they're asking by 90th percentile. What that means is you're doing better than 90% of the population. So essentially we're looking for what number would land us like right here. And that would be an X value that we're looking for. So first thing I need to do is go back to my normal distribution table and figure out which of those Z-scores is going to give me a number that corresponds to 0.90, which is the same thing as 90%. So that is my 90th percentile. Any questions on that? Okay, I'll take that as a good sign. So I'm going back to my table, and now I'm looking inside of the table, and I'm trying to find which number gets closest to 0.90. So I'm going to zoom in a little bit, and I suggest you guys do the same. And let's see. If I get my little pointer, then I see two numbers right here, and that is 1.28 and 1.29. So if you look, then 1.28 lands me at 0.8997, which is only 0.0003 away from that 90th percentile mark, right? Now, the other case that I have is 1.29, which gives me 0.9015. Now, that one is actually 0.0015 over, so it's closer if I use the other value, 1.28. Are there any questions on why I'm picking that value?
No.
No, good.
Okay, that is what I like to hear. So I'm going to go back to the previous slide. And then now that I know that my z-score is 1.28, then I'm setting that equal to x minus my mean, which my mean was given to be 125, right? And then I'm dividing that by my standard deviation, which in this case is 24. Any questions on that?
Now, Linda
No.
is going to solve this for you and give you a number, but I'm going to suggest that everybody, and certainly if you have a question about this, you certainly can ask Linda. But the thing I'm going to ask you in the next step is you solve this equation for x using your calculator or using Excel or whatever you've got, and then we'll compare that with Linda's notes, but you want to try that yourself. So now, are there questions about what Linda wrote? And if not, just start solving that for x.
So quick question again. We're going from percent to the number, but we're going from z space to x space. Is that what it would be?
Yes.
Okay.
So the number that we started with, that 90%,
Right.
was the inside of your z-score table. We used
Okay.
that to figure out what the z-score actually was, which was 1.28. And then once we have that, we can plug it into our z-score equation to solve for x.
Okay.
All right, so when I solve this, then I'm getting 155.72. Would anyone agree with that? Or if you'd like to disagree, that's welcome too.
I
I
agree.
got that too.
Okay. Then our reading speed for a sixth grader whose reading speed is at the 90th percentile would be 155.72 words per minute.
Do we
Am I
round up any of these results, or we just leave them how they
Yeah,
are?
I mean, if you round it, then it's not the end of the world. So 156, why not?
Okay, very good. Now,
Sorry. Is this the same formula as the one that we have in that other page where it's like from
Yes, this is exactly the same formula that we used for the previous formula. So z equals x minus mu over sigma.
But what about
The
the one
only
that was
change is
x equals when it's x equals mu plus?
yeah, so that would just be rearranging this.
So
So
it's
if
the
you
same.
multiply both sides by sigma, then you get z times sigma equals x minus mu. And then if you add mu to both sides, then now it's mu plus z sigma equals x.
Okay.
but
Thank you.
instead of trying to memorize more than one formula, it's the same formula as what Linda was saying. Now I'm going to read part B now. Now part B says, a school psychologist wants to determine reading rates for unusual students, that is both slow and fast. And you might call one gifted and the other, I don't know, not gifted, I guess. But anyway, that's not right either. But anyway, determine the reading rates for the middle 95% of all sixth grade students. Now, so Linda, I don't want you to do this calculation, but I do want you, please, in the remaining 5 minutes before the break, to talk about going after the middle 95% of all sixth grade students. And I am telling you, and this is looking ahead to something we're going to be studying later, whenever we do confidence intervals, and we will talk about 95% confidence intervals, we will be finding, in fact, always on the confidence intervals that we talk about in this class, we will always be talking about the middle 95%. And Linda, I don't know if I was clear to you or not. I hope maybe I was. Kathy has a comment first. Go ahead, Kathy.
When you're saying confidence numbers, would that mean we would take 2.5 from the
No,
extreme?
no, here's what I'm saying. In fact, I'm saying something stronger than that. This is something we're going to talk about later. That's why I chose this problem. But don't worry about what we're going to do later. Just worry about following Linda's discussion about where the middle 95% is.
Okay.
So
Go ahead,
what
Linda.
Professor Bradley is saying is if we're taking the middle 95%, then we need to think about where the cutoffs actually are. So my middle 95% is going to be like here. But then how much of the area is in the left tail and how much of the area is in the right tail? Well, since your normal distribution is symmetrical, then it would be even, right?
Right.
So if there's 5% remaining, what is 5 divided by 2?
2.5 on each end.
Yeah, exactly. So there would be 2.5%. Now that's not necessarily the z-score, but actually if you guys remember that empirical rule that we talked about, like, I think last week, then the middle 95% actually corresponds to plus or minus 2 standard deviations away from the mean. So we already know what our z-score needs to be, and even if you didn't get that 2.5%, then that would be something that you know from the empirical rule. So you can find the z-scores using the table, but you don't necessarily need to for this particular problem.
And so what are these numbers then, Linda, please?
So this is within 2 standard deviations of the mean, so it's going to be a positive 2 over here and a negative 2 over here. So then if I'm finding the actual reading rates, then I'm just plugging these into my same z-score equation to solve for x. So I'm going to have 2 equals x minus that 125 again over 24. And I'll solve for x there. And then I'll do the same thing except with a negative 2 instead of a positive 2. So if I plug these into my calculator real quick, then I'm getting 173 is my upper limit. So students reading faster would have to be greater than 173. Or if I make that into a negative 2, then it would be less than 77. So these are my cutoffs for unusual readers.
Could you show me the very last few steps, how you got to the 173? I'm sorry, I lost you.
Yeah, so all I'm doing is solving this equation. So first you're doing 2 times 24. So you should get 48. And then you're adding that 125 to the other side. So 48 plus 125 will get you that 173.
I guess I'm wondering, how did you know that it would be 2 instead of 2? If the standard deviation was 24, couldn't you also have done it as 24 plus 24 would? I guess I wasn't sure why you started with 2, and how did you know that was an x, not a z?
So the 2 is a z. Are you talking about the 173?
No, I understood where you were saying it's 2 standard deviations would get you to, like, if you're on the positive side, 97.5%. But then I was thinking, I'm confused. Why did you say 2 is the z, and wouldn't you use the standard deviation of 24 words per minute that they tell you in the problem? How did you know that's that was, I guess I was confused how you went that way, or why you went that way.
So if I'm understanding you correctly, you're wondering why I did 2 times 24 instead of just doing 125 plus 24 plus 24?
I guess I thought you would use the 24 words per minute of your standard deviation, and you would add 2 of those to get 48.
Yes.
And then you could take the mean was 125, add 48, and then that would be your line, or that would be your words per minute for someone in the 97 percentile. Is that?
Yeah, so you did it the exact same way that I did. I just did it in a more generic way because let's suppose that they didn't say it was the middle 95%. What if they said it was the middle 94%? Well, then I wouldn't automatically know that my standard deviations were supposed to be 2 and -2, right? Like I wouldn't know that these z-scores were supposed to be these numbers.
Right.
So then I would have to go to that normal distribution table and I would have to actually figure out, well, which z-scores correspond to which areas. And if this was 96%, well, then I would have 4% remaining. So then I'm looking for 2% on either side, right?
Yeah.
So I'd be
Now,
looking for the z-scores corresponding to 2% and then 98%.
Now, the empirical rule that Linda was talking about, and she was correct in doing this, and I was pleased with what she did. But if you went to your table and actually looked this up, it really is not 2 and -2. It's 1.96 and minus 1.96. Now, these numbers are going to be close enough that you get pretty much the same answer. So that's nothing to worry about, but I am making that comment. We are going to break right now. This class is pretty well planned. We're at 7:17. We're going to reconvene at 27. I think people should, take care of their needs, or if they're taking care of some other people's needs or other friends' needs, that's fine. But we'll reconvene at 7:27. We're on break now.
Kathy, can you hear me okay?
Yes, I am. I didn't leave. I just kept trying to do the problem, and I didn't understand.
You are
I
absolutely
got really
fine.
lost.
So that 1.645, then I think what that number is actually referencing is if you look at your z-score table, then that's going to be the 95% over to the left.
Right. Okay.
So what they're actually asking for is the middle 95%. So that means that you're going to have 2.5% on
Right.
either side. You didn't take that into account. So what your diagram should have looked like is like this.
2.5 on one side and 97.5 on the other?
Yeah, so those would be the z-scores that you're actually looking for.
Oh, okay. So if you find those, then you would subtract. What would you do once you find? You would subtract the small one from the larger one?
Once you get the proportions, yes, you wouldn't just subtract the z-scores.
Okay, we're back. And we're moving into something else, okay? Now, these are going to be, the grace notes are you're going to have, but you see, I'm assuming that you watched the videos on, you know, the least squares line and things like that. So these are some important equations that Linda's probably going to be referencing as she does some of this and so forth. And so we have the formulas for the correlation coefficient. We have the coefficient of determination, the capital R squared, and we have equations for the least squares line as well. And so we have, you know, we have formulas for all of those things. And so that's what we are going to do, and we're going to be using this, and we're going to be working problems. And let's go directly into a problem. Now, Linda, here's what I would like to do, and we're going to do two things here. But first, we're going to go through and actually do the equations that we have for those things. So we're going to go then, Linda, to the Bears database. And the first thing we're going to do is we're going to do head length. Okay, so if we can go then to the Bears database, that everybody knows that Linda's going to be going there. And let me just tell you what we're going to do. We're going to do head length with the formulas, and then Linda and everybody else, we're going to talk about shortcut Excel formulas. That mean you don't have to do that calculation, but we're going to do that calculation once to do it. Then we're going to use the shortcut Excel formulas for that, and again, you'll be able to do that on the you know, on the assignments, and when you're doing you know, the midterm and things like that, you'll be able to do that, but you have to know where they are. And Linda, eventually, just so you have a sense of where we're going, I'm going to look at head length, we'll look at neck girth, chest girth, and length, and we'll decide which of those is best and which of those is good enough to use. So that's kind of what we're going to do. But we're going to do head length first, and head length is going to be, so we're looking at head length being the X, and the bear's weight is going to be the Y. And Linda, I'm turning this back to you now.
Okay. I was having a little bit of connection issues, so we'll see if I'm good. Can everyone see this okay?
Yes.
Yep.
Okay, so we're just coming up with the regression equation for head length and weight.
In fact, Linda, do a scatter plot of that to start, if you will. And I know that wasn't
Okay.
what the directions said, but do a scatter plot of head length and weight.
All right, so first thing that I'm doing is actually just copying and pasting my data so it's right next to each other. And that's just going to make it a little bit easier for selecting things and making my actual graph. So all I'm doing is just Control C and then hitting my cell and Control V. And then to make a scatter plot, then I'm going to highlight both column K and L, so all my data from those two. And then if we want a scatter plot, then I'm going under Insert, and then just a scatter plot function. So this looks good to me. And there we go.
Now, the reason that I'm asking Linda to do that is that's one of the things we covered, and I do expect you to be able to do that kind of a thing. And what you might then want to do is, you see, you're going to be turning in PDFs. So Linda, I know we've talked about this before, but could you show them how you could copy that and paste that into a PDF? And Kathy will recognize you as soon as we do that.
Yeah, absolutely. So all I'm doing is just selecting my graph and hitting Control C, and then I will open a Word document. And just a blank document will be fine, and Control V.
Okay, Kathy.
Where is the head girth on this?
Oh, sorry, that wasn't me.
So we're doing head length. That was column D originally. And then I
mean,
just
on the
copy and
scatter
pasted
plot,
it
where
into.
is it?
Okay, so that is your X value. So that's across the X axis.
That wasn't, I have a question still. That wasn't me.
What's up, Kathy?
I'm just wondering if you switched, did they automatically set the weight or the head length to the x-axis and the weight to the y because of the order you put them next side by side? Or how does that, like, if I wanted to switch it? How
Yeah, you got it.
Okay.
So I'm pretty sure we could also switch it up if I go under more details. I just kind of did the automatic one. So if I go under here and look at more scatter charts, then let's see. There should be a way to switch them. Or I may have to go under the variables, but that's why sometimes it's easier to just copy and paste the data so it's next to it.
Okay, all right.
So if I were to go through this and actually just switch column K and column L, then it would do it automatically.
Okay.
Okay, now when you look at this, you don't necessarily realize that that's going to be a line. That's kind of all over the place. So the question is this good enough to use? So what's going to happen is Linda is going to calculate using the formula to start with. She's going to calculate the correlation coefficient for this using the data.
Oh my.
Yeah,
All right, so this is going to be a little bit of legwork. So first I'm going to, let's see, we'll insert
Linda,
a column here. Yeah?
you're only going to do it once.
Okay. So I'm going to use head length as my X values and my weight is my Y values. So the first thing I need to do is subtract off the mean from both of these. So this is going to be X minus X bar. And then column N will be Y minus Y bar. So just off to the side here, then I'm going to figure out what the means are. So that's going to be equal average. I'm opening a parenthesis, and I'm just finding the average for my head lengths right now. So this is my X bar. I'm closing my parentheses, I hit enter, and that is my mean for X. Okay, so I'm actually going to insert a column in front of this. That way we can kind of label these. And then this is my weight mean. So for that, I'm going to do the exact same equation. So equals average open a parenthesis, highlight my data. Close the parenthesis, hit enter. So those are my two means. So now what I'm going to do is subtract off each of those. So equals, I'm taking my column of head lengths, and then I'm going to subtract the mean. So the mean is in cell K2. So I'm going to do $K, $2, and then hit enter. So then I'll take that formula and drag it all the way down. Then I'm going to do the same thing for the y minus y bar. So that's going to be equal. I'm taking my weight column, and then I'm subtracting the weight mean. So that's in cell K3. So that's going to be $K, $3. I hit enter, and then I'm going to drag that down. Any questions about this step so far? Yeah?
Can you just, what is the name of your finding is this the standard deviation, or what are you trying to find?
So
right now?
what I'm finding right now is the correlation coefficient.
Linda, go back to the equation on the other page, if you will.
Was
Okay.
was that called anything else in the videos? I'm not remembering that term.
You may have also seen it as a lowercase r. So this is the formula that I'm using right now.
It's Kathy, it's called exactly that in the video.
Okay. Don't remember.
And but Linda just pointed to the formula she's using.
Okay, right.
So the next thing I need to do is divide by each of my individual standard deviations. So that S sub x just means the standard deviation for my x data set. And then S sub y would be my standard deviation for the y data set. So I need to figure out what each of those are first. So I'm going back to Excel. And this is going to be head length S D for standard deviation and weight SD for my weight standard deviation. So to get these, then I'm just using my standard deviation formula. So that's going to be equaling, let's see, STDEV dot S, since this is a sample of numbers. And I'm doing that for all of my head lengths. I close my parentheses and hit enter. And then I'm going to do the same thing for weight. So equals STDEV dot S, open a parenthesis, and this is for all my weight values. Close my parenthesis, hit enter, and those are my two standard deviations. Are there any questions about that? Yeah?
So these were standard deviation samples, not population, correct?
Yes, that is correct.
Okay.
And if you ever use, then looking at the formula can really help, since the variable used here is S, right? So that means that the data that we're using has to be a sample.
Gotcha. Thank you so much.
Okay. So next thing is dividing by those standard deviations respectively. So I'm going to go back to Excel, and then in column P here, then I'm going to have x minus x bar over S sub x. And then very similarly in column Q, then I'm going to have y minus y bar over S sub y. Yeah?
Is that the formula for Excel, or you're just labeling that for yourself?
I'm just labeling that, just so we know what we're actually dealing with right now.
Thank you.
So in column P, then now I'm taking that equals x minus x bar column, so column n, that was why we created column n. And now we're dividing that by my standard deviation for head length, and that is in cell K4. So that's going to be $K, $4. I hit enter, and then I'm going to drag that down. And then very similarly, then I'm going to do equals, take my value for y minus y bar, and then divide that by my standard deviation for my weights, which is going to be in cell K5. So that's going to be $K, $5. And remember, we're using those absolute cell references, so it's not going to change when we drag down the formula. So I hit enter, and then I'm going to drag that down. Any questions on this step? Okay, so we've divided everything. Now, if I go back to the PowerPoint, then I see my next thing is actually multiplying those two values. So I'm going to take those two columns that I just created, and I'm going to multiply them. So if I go back to Excel, then I'm going to call column R just a multiplication symbol. Or actually, I'm going to call that P times Q for those two columns that I'm multiplying, okay? So equals, and then I'm just taking each value and multiplying it together. And I'm going to do that all the way down. Any questions about that? Okay. Yeah.
Is this is probably a silly question, but is this for the slope of the line then? We're seeing how far for every time the x value goes up one, what the y value does, or what is the?
So this is just a correlation coefficient. It's going to tell us if the regression line that we'll make later will be good enough to use. Because if the correlation coefficient isn't good enough to use, then there's no point in creating the line, right?
What do you mean wouldn't be good enough to use?
So if the data is too spread out and we can't get that linear pattern that we want to see,
okay,
then we're not going to get a strong enough correlation coefficient. And by that, we're not going to get a correlation coefficient that's close enough to 1 to merit using the line.
okay.
And one of the things that happens sometimes is you might have watched the videos but not understood everything. But now we're talking about these things, and you might say, "Oh, gee, I really want to go and watch that video again about the correlation coefficient." And certainly it's there for you to watch again. And again, those videos are pretty slick. Okay, Linda, go ahead. We're almost there.
Okay, so now that I've multiplied those two, if we look back at the formula, then the next thing is that summation, that capital sigma, right? So I need to add all these together. So I go back to Excel, and underneath that P times Q column, then I'm actually going to call this sum. And I'm going to use my sum formula, so equals SUM, open a parenthesis, and then I'm going to highlight all my data in that P times Q column, close my parenthesis, and hit enter. So this is the sum of all of those numbers. So I have my numerator. Now I just need to divide it. So we're dividing by n minus 1. Now, how many data points do we have? Well, it goes down to 55, but the first column is just labels. So 54, right? Yeah?
Is there an explanation you can explain of why, just so I could to remember it better, why are we taking n minus 1 and not just dividing it by the number of data points?
That's the
So
formula.
because we're working with a sample, all you need to know is just this is the formula.
Okay.
You'll have the formula during the test, and honestly, there's an Excel shortcut that we're going to show you in like less than 2 minutes. So don't worry too much about it. Just kind of follow along for right now.
Okay.
So n minus 1, if n is 54, then n minus 1 has to be 53, right? So then I'm going to divide these two numbers. So sum over n minus 1. And that's just going to be equals, take that, divide it by n minus 1. So my correlation coefficient here is 0.834.
Now, in the video that I asked you to watch, they said, yeah, this formula takes a lot of work to use. And they also said that there's technology that enables you to do this more quickly. And now Linda is going to, and you saw, and I don't know if Linda spent 10 minutes doing that or 15 minutes doing that, but she did it very efficiently and things like that. But now what she's going to do is she's going to show you how to get this right away. Now you want to pay attention to actually both of these things because you do want to understand where this comes from, but also you can do this shortcut step that she's going to talk about now. And so this is going to give you the correlation coefficient.
Okay, so all I'm doing is just typing equals CORREL. And you can see that even gives me the description, returns the correlation coefficient between two data sets. So I'm going to open a parenthesis, and you see how it's telling me I need to highlight array 1, comma, array 2. So I'm highlighting my first set of data. And these are the original data points, not anything that I've modified to figure out our previous thing. So I've got my first data set. I'm going to put a comma, and then I'm going to put my second data set. So that would be the weight. And you see how it shows up in a separate color. So then I'm closing my parenthesis and hitting enter. And what do you know? We got the same answer.
Well, I'm not surprised at all because Linda's very good at this, okay? But you see, but which one was faster? The Linda doing that calculation with all those decimal points, or doing this one, and it's doing this one. So that is 0.834. Now, Linda, let's find, yes, Mariella.
So for a test or something, are you gonna require us to like do all this work, or you're okay?
No,
with
I'm going to repeat what I said like 2 minutes ago. Okay?
I'm sorry.
By the way, I didn't mean it to come out that way. But I mean, repeating things is good. I will let you do this, but you have to know how to do this. And in fact, we're going to test right now if you know how to do this. Because now I want you guys to find, and Linda will do this with you in a minute, but I want you guys to find out what's the correlation coefficient between weight of the bears and sex of the bears. And Linda will probably type here that this was weight and head length, I think, or something. We want to keep track of that.
Okay.
So everybody is trying to find out what's the correlation coefficient between the sex of the bears and the weights of the bears.
And for the record, everyone, it shouldn't matter which one you put first.
For this, it doesn't matter which one you put first. Whenever we're finding
Yes.
the slope and intercept, it will matter big time. And again, this was covered in the videos that I asked you to watch. And really, I can't stress too much that, you know, watching those videos more than once is a pretty good thing. Now, so what happens there is, yeah, Kathy.
When I try to open up the Bears document in the syllabus, nothing opens for me ever, and I'm not able to. I don't know how you're supposed to open it and copy it, and is that going to be a problem on a quiz or test? I'm not able
It
to
will
open it up.
it will be, Kathy, if you can't do that on a quiz or test, or no, let's
I
just say on
don't
the
know
midterm.
why.
Well, yeah, but I think the way we debug that is probably, and I am going to be going to my office hours after this, and you're certainly always welcome at my office hours or Linda's thing or Tom Topol's thing or whatever. But I'm telling you, you do want to know how to do this stuff because we will ask you to do these things. So, you know, that is what you want to do. But I'm also going to tell you, don't worry a lot about this because that's just, that's something that's happening with your Blackboard thing. And we can work through that later. Okay. But that is something you
Okay.
want to have debugged before you get to the test for sure. Okay, now what we did is we got weight and head length, and we got weight and sex. And Linda, what were the two other things, or maybe there's three other things that I asked the students to do on that one chart? I think there was chest girth and what
Let's
else?
see. Neck girth, chest girth, and length.
No, we did head length. We didn't do length yet. Okay, so we've done 2 of the 5. You guys find the rest of these correlation coefficients, and Linda will do the same, and we'll compare notes and see what we get.
Jim, I have a question. This is Kathy.
Yes, Kathy, go ahead.
I'm able to access it, and I know how to. I mean, I open and download things all the time from Blackboard. I don't know why the Bears is not opening, and it's not coming up as anything. It's not even showing that it's a PowerPoint or that it's an Excel doc. Do you know, is there another way to access it other than the syllabus?
Well, it has to be, I mean, it has to be somewhere. That's where it is. I mean, that's where it is right now. And again, Kathy, this is one of the things that, and there's a lot of things I really hate about teaching this way.
Right.
But you see, if we were in a room together, I would just go over and look over your shoulder and say, oh, you need to do this or whatever it is. Here, that's not, and again, we'll figure it out. So, I mean, don't worry about that now.
Okay.
But, and
I
maybe,
believe for the midterm, then the data sets will also be emailed out.
Okay. Yeah, I'm able to open a lot of other things, and they're all listed as either PowerPoints or PDFs. But the Bears just says Bears, and when I click it, it says sheet 1, 2, 3, but nothing will open.
and by the way, I'm thinking we'll figure this out. But it sounds like other people are able to do this. I'm hoping anyway.
I don't know.
Linda, you opened it this way, right?
Mine
Yeah, I
did.
took it right from the syllabus tab.
Mine worked with the syllabus, but it took a while to download, but it worked. I just keep insisting.
I mean, my computer froze while I was downloading it, so I mean, I wouldn't be surprised.
Yeah,
Here's what I'm going to suggest, Kathy. Make sure that you tag up with either me or Linda, and I'm happy, if you come to my office hours, and we'll figure out what's going on. Okay?
Okay. Okay, thank you.
All right. Okay, so Linda, what we got here? Linda's got all these numbers. Now, you guys should have gotten the same numbers. Now, these are measures of the fit. If this was a perfect positive correlation, the correlation coefficient, and you learned this in the video, would be 1. If it was a perfect negative correlation, it would be -1, and everything else is in between. But this is another thing you learned in the video. The closer you are to 1 in absolute value, the better the fit. So Linda, which of these is the best fit of the data and why?
So that would be the chest girth and weight because it has the number closest to 1 or -1. So in this case, that would be 0.963.
And Linda, the crappiest fit of this
Sorry,
data is
can you just repeat what you said? I was trying to get these problems done on my own, so I am lost now.
So we just said that the chest girth and weight has the best fit because it has the number closest to 1 is the correlation coefficient. And that could be a number closest to -1 as well, depending on if the correlation is positive or negative. Basically, you just want to be furthest from 0.
And of these things we looked at, Linda, which one is the worst fit of the data?
So that would be weight and sex. We'll make that a little bit darker.
Okay.
And that is because the correlation coefficient here is closest to 0 at -0.189.
But another thing that we learned, and by the way, you learned this in my video, not in the video that we watched, I think, because it really comes from the lecture that I've taken from the Sullivan book, but we use another table. So Linda, if we could, please go back to the PowerPoint slides. And there is the table. Now, this table is going to be in your Grace notes. It's a table in your book, and you have it in your PowerPoint slides right now, okay? But this tells you, and Linda, I will let you speak to this, but this answers the question, is it good enough to use? And that means, is it good enough to use the line you get, the least squares line? Okay, so Linda, go ahead, please.
So depending on what our value of n is, that's going to tell us if the correlation coefficient is actually good enough to use or not. So for some of these, then we have quite a high number, like 0.96. So, I mean, we have 54 data points, I believe. Our table doesn't actually go down that far, but really anything better than 0.361 is going to mean that our line is going to be good enough to use.
So Linda, go back. Are any of those not good enough to use?
So the only one not good enough to use would be weight and sex. And not because it's negative, just because it's too close to 0.
Kathy.
Could you repeat that last part you said of if it goes down to, I think it was what do you mean if it goes down to 30, then it's good enough?
So the values of n only go down to 30. But we have 54 data points. N is the number of data points that you're working with.
Right, okay.
So because we have too many data points that we go off the table, then if you look at the correlation coefficient values that are the cutoffs, then you see that they keep decreasing the higher the n goes.
Right.
So we can kind of conclude that as n gets bigger, then this value is going to get smaller.
Okay, right.
So if we're better than 0.361, then we're going to be better than whatever we needed to be for 54 data points, right?
Right. And if there was a number under 3.361, we would just guess, or what? How would we know?
Yeah, so if they had 54 right here where we could actually look it up, then we'd be
Right.
comparing it to that number.
Okay.
But because we don't have a row 54, then I'm just kind of inferring based on what we know about this table that ours are good enough to use.
Now, I use that slang myself, good enough to use. But one of the things that you're going to see is that in Sullivan's book and also in some of my lectures, the phrase that is used is not is it good enough to use, but does a linear relationship exist or not? So this table that Linda showed you is the one we use to determine if it is good enough to use or not, or said another way, is there a linear relationship that exists between the two variables? And this is one of the questions I'm going to ask you. And so you do want to know how to use this table. And again, some of these videos you may want to watch again to hear some more examples of this. Now, so Linda has concluded for chest girth and weight that first of all, that's the best equation that we can have, and it's certainly good enough to use. So what we can do now is we can find what is the equation y equals mx plus b. The x is going to be chest girth, and the y is going to be weight, and you're going to have a slope and an intercept. This is y equals mx plus b. And by the way, there's formulas on that grace notes. I'm not going to make Linda use those formulas, but there are shorthand formulas. And in fact, if you go and watch some of the videos I had you watch, the formulas there are really pretty complicated. But what Linda is showing you is how to find the slope and intercept. But you don't even bother finding the slope and intercept unless it is good enough to use. So Linda is going to now find that. So go ahead, Linda. Let's see, what is this? Are the grace notes located in the syllabus? The grace notes are, I'm showing you pieces of the grace notes, and one day I will show you the grace notes that you will have for the midterm. But what I'm doing is I'm just taking the end notes, and I've been showing you bits and pieces of the grace notes. So Linda, go back to that PowerPoint slide where we had the equations.
Okay.
Please. This is a piece of the grace notes. And so what happens is there's equations down there that are for that, but Linda's not using that because I'm letting her and you use the shortcut formulas. Okay, so Linda, I'm giving it back to you. I tried to answer that. I think I did. Okay, go ahead,
Okay.
Linda.
So we're doing it for chest and weight. So first thing I'm doing is just labeling things. So we're going to find the chest and weight slope, and then we're going to find the chest and weight intercept. So to find the chest and weight slope, then all I'm doing is using the equation equals slope. You can see that literally tells me right here, returns the slope of the linear regression line through the given data points. So I open my parenthesis, and it's telling me known y's go first. So as Professor Bradley said, then the weight is going to be our y. So highlighting those first. I put a comma, and then it's going to ask me for the known x's. So you can see that right here. And because we're doing chest and weight, then chest is my x's. So I close my parenthesis, and I hit enter. So my slope for the chest and weight is going to be about 12.5.
How did you decide which
Any
was
questions
X and
on
which
that?
was Y?
Professor Bradley told us that chest is going to be X and weight is Y.
So it was just
Now,
based on what was said. There's no like, how do you know
So
what
that
you're
was
using as
based
slope?
on what was said. In a problem, if you were doing it on your own and not in class, then you would have to consider which is the explanatory variable and which is the response variable. So X is always going to be your explanatory, Y is always going to be your response.
Okay.
in the video that you guys watched, what happened was that they were concerned about manatee populations and water boats. Okay, boats in the channel. Okay, are boat registrations, and so which one influences the other? Do you think that the number of manatees influences how many boats get registered? Well, I would say probably not, because what happens is that, I mean, people don't buy boats and register boats to go out and look at manatees. What they really do is they go out just to have fun. But it does go the other way, because as you learned in the video, that the more boats you have, the more manatees that are injured and die because of the boats. And so the manatee population decreases the more boats that you have that are registered. So you see, X is the independent variable. That's the one that explains the Y. So as Linda said, a lot of times you can conclude that one influences the other. For example, let's talk about my weight, my body weight, and the number of calories that I consume. Well, which one really drives the other? Well, the number of calories I consume is the X, and that drives my body weight, not the other way about. So sometimes it's clear, other times it is not. A lot of times, and in fact, in the problem that I think I gave you for a low stakes assessment, it was talking about number of cricket chirps and temperature. Which one? And Linda, let's do a poll. Okay.
Okay.
So we're talking about cricket chirps and temperature. Okay. Which one is the X? The temperature or the cricket chirps? And you're saying which one influences the other? Which one responds to the other? Which one explains the other? And again, don't worry about being right or wrong, just answer it. Which one explains the other? And what did Linda add? Oh, she asked which one was X. That's good.
Jim, can you remind me what is the X is called the explanatory and the Y is the what variable?
It's
The
called the
response.
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 And that's what it's called in the videos that we talk about. And that's actually what it really means when you pick, I mean, when you're doing your math and you're saying y equals f of x, you're really saying, oh, I pick x and I can figure out what y is. So y depends on x. So I know that's some different terminology. And I'm satisfied that most people understand this. This is good, because you see, the higher the temperature, the more chirping of crickets you're going to have. But do the chirping of the crickets, them rubbing their legs together, does that cause the temperature increase? Well, no, I don't think so. So sometimes it's very clear, sometimes it's a little bit arbitrary, but those are the things. Now, okay, so that is the slope and the intercept. So Linda, what is the equation then that we have for this one?
So we do still need to get the intercept. So for
I'm
that, then I'm
sorry.
doing the equation equals intercept. And once again, it gives you the description for the best fit regression line. So, yeah.
Is the intercept the B? I'm trying to remember if that was the M or the B.
So that would be your B sub 0 here, or B in your algebra class when you learn y equals mx plus b.
And the B would be where the Y line crosses. At what point?
Yes,
crosses?
where it crosses the y-axis.
Okay.
So when x is 0, this is what y is.
And the slope is the rise over the run.
And then once again, I'm just highlighting my weights, comma, and then I'm going to highlight my chest. There we go.
Kathy, is your hand up again, or is it just still from the other thing? I can't.
Oh.
Okay, good.
Sorry.
All right, great. No, don't worry. It's fine. I didn't want to miss a question. Okay, so Linda, what does this tell us about the equation then that we have for this?
So then my equation would be about y equals, so I'm just rounding here, 12.5 times x, and then I would have minus that 264.48. So I'll just call that 0.5. So this would be my actual regression equation, and I would use the actual values that Excel gave me if I were to plug something in, but this is what it would look like if you were writing it down for an exam.
Okay, so Linda, suppose that there were a bear that had a 45-inch chest girth. From this equation, what would we expect that bear's weight to be?
So if x is 45, I'm going to put that right here in column L. Then I'm going to figure out the y value by plugging that in. So I'm doing equals, I take my slope, and I'm multiplying that by the 45, and then I'm adding my intercept. So the reason why I'm adding is just because that is the general formula here. Even though it's a negative number, then that'll change it automatically to be subtraction. So you do want it to be a plus, though. So I hit enter, and I get about 300.
Okay, so you see we do use this regression equation to estimate things, and that's very much the question I posed to Linda is very much one of the questions that I would ask you to do. Now, Linda, a bunch of these equations were good enough to do. That was the best one. Why don't you pick another one that was good enough to use and ask the students to find the slope and intercept for that? And that lets them test to see if they know how to do that.
Okay, then let's do neck, girth, and weight.
Yes, Kathy.
Can you review, how did you find the slope? I know it's rise over run, but what did, for instance, with the chest and weight slope, how did you arrive at 12.544?
So the equation I'm using is the Excel command equals slope. And
Okay.
then you list out your y's and you list out your x's.
You just copied all of your, I can't tell what it is on there, all of your data
Yeah,
points.
so if
for-
I do this again, so let me label this real quick. So neck and weight slope. Then I'm doing equals slope, open a parenthesis, and it's asking for the known y's. So I'm going to give them the y value first, which is once again the weight. So I'm highlighting those, I put a comma, and then we want the neck, so I'm going to my neck column, that is F, and I'm highlighting those data values. I close my parenthesis, I hit enter, and it spits out the slope for me.
Is it essentially adding all of your weights and then dividing them by all of your necks, or?
So what it's really doing is it's applying this formula. So they're taking that R that we got by computing the correlation coefficient, and they're multiplying it by the standard deviation of the y's divided by the standard deviation of the x's. So you can find it by hand. I would not recommend it.
Yeah, okay.
Does that answer
Linda,
your question?
No, I'm very confused again. That's okay. I'll come to the helpline.
Are you okay using the slope command?
I can't access the bears data, so I can't try it right now, and I don't want to leave my Safari page and try to open Excel and end up being kicked out of the Collaborate. I've never been able to do Excel while we're on the program, on the class, so I don't know. I can watch you do it.
Okay.
I kind of understand what you're doing, but I didn't go
Yeah, why don't you
understand
come to GSG tomorrow and we'll take another look at it, okay?
Yeah, thank you.
Yeah, no problem.
Hey, Linda, let's stay on this slide for a moment, okay?
Okay.
Back to the other one. Or I don't know, did you still have to find the intercept on that one?
Yeah.
Why don't I let you finish that, then we'll go back to this. Go back and finish what you were doing with the intercept on that one.
Okay. Let's see if I can spell today. Okay, all done.
All right, now the reason I was asking Linda to do that was so you could sort of check yourself. And again, that's assuming that you could open the files and you know, you could check this. And maybe that's not convenient here. I will tell you, and again, it is what it is, and we're doing the best we can. But it's so much better when Linda and I are in the classroom, because we ask you to do something, and then you're all trying to do it. You're sitting there, and you're sitting next to someone, and that someone might know how to do it, and they can help you, or Linda and I can walk around and help you. So that's way better. But we just don't have that right now. But we have ways to get it done, and we'll be fine. Okay, Linda, thank you on that. There's one more thing I want to emphasize, and Linda's going back to the other PowerPoint slide. And this is another thing that I talked about in the video. Now, again, if you're not watching the videos, you know, you come here and you probably say, wow. And Linda, this is the equation that I'm looking at. And I don't know if it's behind this or in front of it. It's there, very good. Okay, this is the last concept that we really have, called the coefficient of determination. Now, this is called capital R squared. And the definition that I give you, and I talk about this in the video, the definition is, this gives you the explained variation over the total variation. That's the fraction of the variation that is explained by the regression equation. And so, gee, if this were a 1, that would mean everything is explained, but you can get, you know, a bunch of things that can be explained. Now, capital R squared for a single variable linear regression is lowercase r squared. It's a different thing for more variables, but it's that. So what I'm going to do, and you can see that that shows it here, capital R squared, eventually down there on the last line, it shows that that is little r squared. So Linda is going to go back, and she's going to go back to the chest girth weight equation, and she's going to calculate r squared, capital R squared, and she's going to tell us, what does that mean? Okay, Linda, you can go back to your spreadsheet now, please.
Okay. And we're doing that for the chest and weight?
Yeah, yes.
Okay, so I'm just going to put that underneath here as capital R squared. So when I do this, then I'm doing equals, and I'm literally just taking that value of R that we got. So in this case, it was at 0.963. And I'm raising that by doing Shift 6 to get the caret, and I'm squaring it. So what this means is that about 92.8% of the data is explained by this regression line that we created.
Yeah, so you have that percentage of the variation is explained. okay, that fraction. And that's pretty good, because that's saying that this that equation that we have with chest girth is pretty good, because that explains over 90% of the variation, okay? And you might say, what lurking variables might be there? Well, some lurking variables might be an illness. If there is some kind of bear disease that's going around or something, and one of the bears got it, that, or some of the bears have it, that would perhaps influence their weight. But this really does a very good job of explaining that thing. Now, Linda, I'm going to suggest that you, and by the way, if I'm saying something that's really hard to do, you just tell me it's hard to do, and maybe we won't do it. But can you go back to the syllabus tab and call up the LSA, whatever the LSA is that deals with the regression?
Yeah.
I'm not sure.
Is
I
that
don't
the
think
latest?
No. The latest one is going to be something, I'm going to guess it's 4, but that is a guess. So click there, if you will. And I'm hoping this
There we
one is
go.
right. Yes, it
Chirps
is.
and temperature.
Okay. I'm going to just read these to you. Okay. Now, first of all, you have some data there. And this is data that I didn't give you a file for, so you have to enter this data. But gee, you can do that, okay? And look, whoever, Michael Sullivan, I guess, when Michael Sullivan wrote this part of his book, this problem, he told you that the temperature was the X and the chirps were the Y. Now, in part A, it asks, what is the likely explanatory variable and why? Well, you guys, we did a poll on that, and you guys were really good at that. You say, well, temperature explains how many chirps. It's not the other way about. But that's the answer to that. But then it says to do things that we've done tonight. Draw a scatter diagram of this data. Linda showed you how to do that. I showed you how to do that also. Compute the linear correlation coefficient between the temperature and the chirps per second. Linda showed you how to do that. Does a linear regression, this is D on the next top of the next thing, does a linear relationship exist? Is it good enough to use? You have to use that other table and explain that. Then it asks you to find the least squares regression line, y equals mx plus b. Interpret the slope and y-intercept. Then you use it to predict the chirps per second if you have a certain temperature. And then it talks of, and then you've got other questions. And then down there on number 3, it says, what's R squared and what does it mean? So you see, this is what I expect you to be able to do. Now, I am not probably on the exam going to ask you the cricket problem, but I'm going to ask you something that's kind of like the cricket problem. So this is what you have to be able to do. Linda, any other comments here, or are you good with that?
No, I think I'm good.
All right, great. We're finished with this part of regression. Now, so Linda, let's go back to the slides we have, and I always know what time it is, and we go till 8:40 in this class, but we're going to do a little bit more. And now what I'm going to start talking about is, we're going to start talking about contingency tables. And so Linda, I'm not sure exactly where we are. Let's see. Yes, Kathy.
I just have a terminology question about regression. When you use the term regression, you just mean a line, like its angle going, whether it's a positive or negative correlation, or what does that exactly mean?
It means a whole bunch of things, Kathy, but I'm going to tell you. First of all, and by the way, I'm going to tell you in terms of things I would expect you to be able to do, okay? I would expect you to be able to make a scatter plot. In fact, I'm going to go back one. I would expect you to be able to speculate about what is the explanatory variable and what's the response variable. I would expect you to be able to make a scatter plot using Excel. I would expect you to be able to construct the correlation coefficient, the lowercase r, and that means find out what is that number. Now you can use the high-powered functions that Linda showed you. That's fine. I'm okay with that. but you do that, and then you also know what that means, because I'll ask, is that good enough to use, or does a linear regression exist or not? That means you have to be able to use the table. I'm going to ask you then, if it's good enough to use, I'm going to ask you to find the slope and the intercept. I'm going to ask you to use that y equals mx plus b to find out the the estimate that comes from the regression line. And I'm also going to ask you questions about capital R squared. Now you might be thinking, boy, that's a lot, but that's almost an entire section in the book, and that's really the extent of what I'm going to ask you. And so, there it is. And I hope, Kathy, that more or less answered your question. I hope it did.
So
And Linda,
regression is just the overarching term for all of it?
regression is all of that stuff. So if later on I tell you, oh, there's going to be a regression question on the midterm, I imagine there will be, then I could ask you all those things in that one thing.
Okay.
Okay. All right. And Linda, we do want to talk about this, but let's go back just to some of those previous slides, because I want to show the students things that they can practice. So for example, here is a problem. Let's see, that's the quarter pounder. Okay. You could practice on this problem. This is a problem from the book. And you see it asks you to do find the correlation coefficient. Does a linear regression exist? So there's a question that's similar to that. Linda, the next slide, please. Here's another one. Now this actually is a more complicated problem, but it's talking about apartments that are in Queens and Long Island. And I don't know if you know much about New York. Actually, I don't know a lot about New York, but I do know that Queens is kind of the blue collar area and Long Island isn't the blue collar area. So I expect real estate is much more expensive in Long Island than it is in Queens, okay? And if we had another borough like Manhattan, the real estate would be, off the charts in terms of this. But anyway, there's another problem. Notice that I asked you to compute and interpret R squared. So you see, these are problems where you can practice. And Linda, let's go to the next one. Maybe that's the end of that. Okay, that is this. Now, I've already posted the thing that's dealing with these, but these are called contingency tables, okay? And we may or may not finish this example tonight, but that's okay. We're doing just fine, okay? We have finished what you need to be able to do for the LSA that's due before we meet again. So, you're in good shape for that. But these are called contingency tables because it depends. And so what we have here is different opinions. These are qualitative opinions about abortion, okay? And so you can see in terms of the rows that Linda has here, some people could say, I think abortion should, and by the way, I'm not trying to make any political statements at all. I'm just saying we're studying the contingencies here. So these are opinions that people could have about abortion. And so some people could say abortion should never be permitted. Abortion, an opinion somebody could have about abortion is it should be illegal with a few exceptions. And some of the, and by the way, these are serious social issues, and we're not talking about that at all. These are just numbers, but this might be, oh, my baby is going to have like a horrible quality of life and is going to die very soon after it's born. But that might be something that some people would regard as exceptions. Other people would say that's never permitted. There are people that might have an opinion that abortion should be allowed, but be more limited, okay? Or some people might say generally available. So those are different opinions that people could express. But then across the columns, we have different also qualitative variables. And we say, suppose someone has a high school education or less. And by the way, that has nothing to do with if they're a good person or not, okay? there are some very valuable and useful people who don't have a high school education. My grandmother was a very wise, well-read woman, but she did not finish high school because it was back then. And then they have another category that says some college. And this might be people who said, well, I did part of a college at DuPage or something. And then there's people who are college graduates, okay? But the question that happens here is, well, whenever we interview somebody, we say, okay, what are you? And so we ask them questions about which one of these column buckets do you land in? And so they answer that, and then we ask them a question and they tell us, and we tally these results. So what we're trying to do with this information is we're trying to understand. And by the way, I made a video about this too, and this is in chapter 4 in Sullivan's textbook. And again, some of you have said, yeah, I think maybe I want to get the Sullivan's textbook. I've given you multiple ways to, get at that and things like that. Maybe you want to get it, maybe you don't. Some students find my notes are good enough. I don't know. But you figure out what you want to do. But I've worked hard to try to have there be cost-effective ways for you to do that. But anyway, this is called a contingency table or a two-way table because perhaps the opinions depend on this, what you're doing. Okay, so and Linda's going to do some of this. And by the way, Linda probably, while I was talking, typed this in. And we're not
How'd you know?
Linda, because you're good at what you do, okay, and so that's why you're ready. And I don't know if I'd give you this. You might have to type it in, but Linda's typed this in now, and we're going to do one thing at a time. But Linda is going to construct what is called a frequency marginal distribution, and I define that in the videos. And if you say, well, I watched the video, I didn't get that, well, you can always watch the video again. So Linda, go ahead and talk about constructing a frequency marginal distribution. Go ahead.
Okay, so the first thing that I'm going to do is figure out my totals. So I'm going to do that for both the columns and the rows. So let's see. And for this, then all I'm using is sum function. So equals SUM, and then I'm going to highlight each of my rows. And I can actually drag that down right away. So then next I'll be doing this for the columns. And I'm just highlighting each column here. So then I'll drag that across. So I'm getting 833 total people were surveyed. So now what I'm going to do is copy and paste this below. And what I want to do is divide each of these numbers by that 833.
Now we're going to pause just for a minute because, and Linda, I'm going to ask about what you did up there, and I know I'm interrupting you, and everybody realize I always know what time it is. Linda, highlight that 317 over through your grand total and the column totals as well.
Okay.
And make them red. Make them red. No, just the numbers. I'm not being clear. I'm not being clear. I'm sorry. Just 317.
So you're saying this?
No. I'm saying go across that total row, make all those red, R-E-D.
Got it.
There you go.
Okay.
Okay, and the columns.
Okay.
Boom. We are done. And by the way, Linda, make that 833 bold, please. Bold italics. What the hell? Okay.
Okay.
That's called the grand total. So what Linda has is column totals and row totals and a grand total. Linda has finished part A because that is a frequency marginal distribution. Okay, so that is what we have, because in the margin we have frequencies tallied. So Linda really is finished with part A now. Now Linda, being Linda, was romping along, and she's going to do, and Linda, God bless you. You know what? That's some of the reasons I love you is because you are, such an apt student. But I wanted to pause there for students to realize you're finished with part A. That's all you need to do. Okay, for part A. Now, Linda is going to talk about relative frequency marginal distributions. And so what now she's going to do is she's going to divide all of those things, but she's saying just relatively what's happening. And so she's changing these percentages, and she's going to divide by 833 everywhere. So Linda, go ahead. Now, these are just going to be margin things.
Okay, so I actually needed my totals as well, so I'm going to copy that and repaste my data. Now you need to be careful when you're pasting it because we did kind of use formulas relative to other cells. So when we paste it, then we want to make sure that we're only pasting the values. So that's that 1, 2, 3 option that I just picked.
And Linda, I think, and I am going to say one thing, and it's not because I don't trust you, but I want to make sure that you're doing this, and everybody understand this. So we're still in the margin because it says marginal distribution. But now
Yes.
This is a relative frequency. So the only things that's going to change is instead of having 317, 240, 276, we're going to have percentages there. Go ahead, Linda.
Okay, so all I'm going to do is just change each of these to be formulas, and now I'm dividing them by that 833.
And Linda, when you're finished with this one, we're pretty much going to be done. I'm going to give a benediction and then we'll be dismissing. So.
Okay.
And Paula, I'm going to stay here and make sure that your question gets answered, but I think I'm almost ready to dismiss the class. Now we're going to pick this up from here, but you got videos to watch on this and things like that. So I am, because I really work hard at this, I am dismissing the class. If anybody wants to stay and hear Paula's question, that's fine. We're going to answer it. But Linda and I, except for answering Paula's question, and if I suppose if anybody else has a question right now, we'll answer it. But we're about ready to turn the recording off. Not yet. Let's hear Paula's question. Go ahead, Paula.
For the LSA number 3, is that one due tomorrow and then the LS for a different day?
All of this stuff is in your announcements, okay? And since you asked that, I'm going to ask Linda to go back to the announcements and find out, or actually, Linda, go back to Blackboard.
I'm on it.
Okay, Linda, go back to LSA 3.
Okay.
Okay, click on that and it will tell you when it is due. Now, yeah. No, that's not what I meant. I was wrong on that.
You meant the spot to turn it in. Got it.
The update. I'm sorry. The upload. I'm sorry. I was thinking correctly, but I wasn't talking good. Paula, hang on. We're answering your question right here. Okay, there.
So yes, that is due tomorrow.
All right, so that one's due tomorrow. But, and I'm trying to remember. Oh, that one's about the normal distributions, which you got. That's the Speedy Lube thing. Yes.
Yes.
Okay, so that's what's due tomorrow. Just to answer Paula's question, let's go to the upload for LSA 4. And that one's due on the 19th. Now that's on Friday. Okay, and that one deals with the regression stuff. But we talked about all the regression stuff in class. You can rewatch the videos. We have GSGs and stuff like that. So that's due in LSA 5, Linda, Now this is the one dealing with, oh, what is that? Contingency tables. Whoa, that's not due until the 26th. That's 10 days from now. We'll have another class before that. Although I've already lectured in the net videos that you're supposed to be watching. Okay, Paula, did I answer your question there?
Yes, thank you so much.
Okay, so that's good. And Linda, thank you for answering that. And Linda, let's shut off the recording. And by the way, everybody, you know, you can leave. I suppose if anybody's got other questions, you can. Well, I don't know. I think we're pretty much finished. I have office hours beginning at 9, and you could take a 15-minute break from me if you wanted to.